Good morning. We are the Immutables, and our topic is decentralized immutable IoT data storage. My name is Hanna Abdeslasi Awazgi. My teammates are Amir Hamza, Mahanur Malik, Tariq Al-Azaz, and Yasin Rabi. So I'll be giving the introduction, problem statement, and then we'll continue on to the solution as well as to the architecture and the demo we have actually provided. So for introduction, what is IoT device and why is it important to actually have a decentralized and immutable storage needed for IoT devices? IoT devices has taken the root of thousands of applications. It is embedded in many fields, many applications, and there are many sensors actually implanted and integrated throughout the world, which means there is a high data that is being generated from these sensors. Therefore, the data needs to be processed as well as analyzed without them being tampered. So the approach that has been taken so far is a centralized approach or a centralized solution has been used, along as well as cloud resources in order to analyze and also process the data. So when we go to our problem statement, one of the major problems with centralized approach or a centralized solution is the lack of trust, because you're handing your data to a third party or you're storing it locally. So people might not trust the data, because if it's stored locally, it can be tampered with, and the data, people may fear that it might not be reliable, as well as when you are actually saving your data in a third party, or you're allowing a third party to actually control your data, which means there's a trust issue there too regarding the reliability as well as the security and other issues that actually come with it. So to build trust, the data needs to be private, secure, immutable, as well as decentralized. This can actually make people more comfortable when it comes to the data being retrieved. So the problem that we are actually addressing is an application required for IoT devices that can keep the IoT transactional information secure, immutable, without using centralized parties and cloud technology, which means we are excluding the third-party involvement in this. So the weather data storage from sensors will be taken as a use case for this challenge. So the solution we have proposed is a blockchain approach. We're not using a blockchain application per se, but we will be using a database that actually has a blockchain characteristics. So we propose to use the big chain database. It is transparent, it is immutable, it is decentralized, and it uses MongoDB, but it also has a blockchain characteristics with it. And the blockchain characteristics will actually solve the security and immutability problem that is being faced right now. And if we actually ask why blockchain, because with its characteristics, it can actually establish trust and also transparency when it comes to the data that is being stored. Okay, big chain database, these are some key characteristics that it has. So decentralization means that there is no single point of entry when it comes to the data, which means the data will be copied through multiple locations, so if one fails, you can still have access throughout the rest. And immutability, which means the data cannot be changed by anyone. It has Byzantine fault tolerance, it's customizable, it's also open source, it has a public or private platforms, and it has a querying applications, and so on. So the solution architecture that we have decided to implement is we decided to actually use 3 different locations, which actually have 3 sensors. This can be different sensor types such as temperature, humidity, pressure, whatever you want. So it will give the weather information of the from the sensors that are implanted in 3 different locations. So we will be using Open Weather API to actually collect the data from the weather and use the MongoDB big chain database as a database. As you can see the structure we have, this is how it actually looks like, and then from this database, we have a UI that will actually be fetching the data that is actually needed, because our application is a storage and retrieval application. Okay, the technologies that we have used, we have the backend as well as front end. We have used big chain database as a database, and we have used Python Flask for querying, and for front end, for creating our UI, we have decided to use HTML5, CSS, as well as JavaScript. So the blockchain database architecture, this is how it looks. So there will be multiple nodes created. The minimum you can have is 4 nodes, and you can increase as many as you want. So within those nodes, there is a database. In this case, in the big chain database right now, they're using MongoDB. So there's a MongoDB database. And in the middle, we have the server. And the third one is the Tendermint. Tendermint is a software that is used to actually replicate data between the nodes. So they use the software this software is actually being used to replicate the data. Because what we need is for the blockchain, the big chain database to do is, for it to be decentralized, we actually have, when it receives one node receives the data, it will copy it throughout the node, which means there will be copies of the same data throughout the network, which makes it decentralized. And since it's a blockchain approach, it's very immutable and secure. So the potential use case of this proposed solution is, for instance, let's assume that the government wants to monitor the air pollution of factories so that they don't exceed the limit that they're supposed to. And to actually make sure that they're actually following the policies that is in place to actually solve the carbon emission problem that we are having these days. So there's 2 approaches that they can actually follow. Either they can actually implant the sensors in the factories or around the plant and actually use a local database, or they can actually use cloud-based cloud services. But the problem is, as I've explained before, the third-party involvement in this, people can easily be bribed, and systems can be infiltrated, data can be tampered with if it's stored locally or in cloud by the providers. So there's a trust issue that has been aroused. So in order to actually mitigate this problem, they can actually use this approach to actually solve the problem. And the interface that we have created is, this is our interface. This is a weather dashboard. Okay, so I have said that we have 3 sensors in 3 different locations. These data will actually be saved in the big chain database, and it will be retrieved from the user interface by anyone. So this is the user interface that we have. We have IoT data, like weather information from Skellefteå, London, Paris. And we also have the weather data. This is the weather data we have, as well as we have decided to save the historical data, so that if people want to do research and people actually want to use it for any purposes, they can actually use this one. This is the graph to actually show how it's actually, the temperature is actually fluctuating, or how it's going so far in the 3 different locations. So we have London temperature, Skellefteå temperature, Paris temperature. The UI really depends on what the customer wants or what you want. So if you want to add more, so you can add like humidity, you can add what it feels like, and so on. So it depends on what we have decided to do is just to present the temperature of these 3 different places, and also our historical data button. It shows the historical data for the past 15 days. So we have the date, the temperature, what the temperature feels like, the wind, humidity, as well as what the weather report actually says. So when it comes to our backend and our storage, the big chain data, this is how it actually looks like. So we have the 3 assets. So we have Skellefteå, London, as well as Paris assets. These assets have an ID as well as an event. And then we have the transaction. Transaction basically means when the IoT senses data, or it generates the data and actually it stores it to the database. That's called the transaction, which means every time there is a new data that has been generated, it will be appended to the existing blockchain. So that's how the transaction looks, and these are the assets and the metadata that we have. And for conclusion and our future work, we have created a user interface as well as a database that actually will fulfill the immutability, security, and so on. So we have gathered data from multiple IoT sensors in 3 different locations. We have employee big data chain. Big chain database is a database with blockchain characteristics for storage as well as the retrieval. And we have decided to create a user-friendly interface which will be easy for people to actually use. And for future work, big chain database is still evolving, but it has an immense potential for. But in also to determine the storage constraint and limitation, there needs to be a rigorous testing that needs to be done for it to be more reliable. Thank you very much. And for our demo running, since it's running on a MacBook Pro, we couldn't hook it up with this one. We can actually show you later of how it actually works. Thank you very much. If you have any questions.
Can you do a quick demo for the jury right now?
Or why are you lacking a cable or an extension?
Yes, you need the USB-C to HDMI.
Yeah.
USB-C.
Right.
I think there is a USB-C adapter here. Yeah, there is a USB-C.
Yeah. Okay.
Okay, so our interface is relatively simple. So basically we have 3 locations. Basically we're using sort of simulated data or data using the API, you can say.
Could you talk a bit louder or use the microphone?
Okay, I'll talk a bit louder. So
Yes.
we have 3 sensors. So to simulate the data from the 3 sensors, we are basically using the API data. We are making use of the open API. So basically these are showing the current temperature values of the 3 cities and also the time at which we took the data. So it's just to show the latest data. So basically what it does is the data is fetched using the sensors of the API, then it is stored to the database, and here the data is displayed from the database, not directly using the API. Okay, so if we want to see the historical data, we can display it in a chart form. Basically, it is querying the database to retrieve the historical data, and it's just displaying it. So we have kept it relatively simple. And similarly, if we want to see the historical data, at the moment we are just displaying the historical data of one city. It's not the actual data; it's sort of simulated data because the Open API has it's not free. If you want to access the historical data, so we just simulated some data to display. So it can be very simple. So what's unique about this is basically the database and the way we are storing it. So basically the main purpose of the challenge was to store data in such a way that it is immutable and it is decentralized. So to do that we need to come up with a different approach. So the way we are doing it, we are storing the data in a distributed manner. So what it does, the main concepts when you are using the big chain database is like each sensor is considered an asset. So the 3 cities or the 3 sensors are considered as an asset. So this is the first asset, second asset, third asset. So if we select the first asset, so each asset has some transactions. So each transaction basically show what the previous data was. Like this was the first transaction, it was basically the creation of the asset. And the next transaction we can say that then we had some data coming from the sensor, like the metadata. So this is the data from the sensor, then we are storing it. So basically it is appending to the previous data, so it is sort of making a chain. So if some third party tries to alter this data, maybe in one of the nodes they try to change the data. Since there is a consensus between all the nodes, so it can be detected if any change is there. So for the weather data storage, it may look trivial, But if you are using some mission critical system, maybe like for factory monitoring, in which the data tampering can have serious consequences, then you need immutability so that if any change is made, it needs to be tracked back, or there needs to be some certain record. So in those cases, it is vital to have some immutability or some way to trace back. So this was pretty much it, and yeah, this was pretty much our. Yeah, thank you.
Do we have any questions or comments?
Yeah.
About the big chain DB, is something like a database that it has a different type of function like drop, delete, remove, add, insert,
Okay,
something
so
like
basically BigChain is based on MongoDB. So it has all the functionalities of MongoDB. So your question may be like MongoDB has a delete function. So can your data be deleted? Yes, it can be. But like data is replicated in 4 nodes. If someone tries to delete in 1 node, so there will be a consensus between the 4 nodes that this person has changed the data. So that transaction will be rejected and it will be detected immediately. So but by default, those APIs are not exposed to the user. So you have to really go in deep to try to alter the data. But if you make any attempt to alter the data, it will be detected.
Okay, it means that it's possible to delete if all the party, all the nodes are agree with.
It's not possible.
Not really.
Okay.
Even if you do it, so your chain will be broken, your hashes will be changed, so it will be detected and it will prevent you from doing that, because at the same time you cannot do it because it needs to have a consensus among every time each transaction is made. So like it has the Byzantine fault tolerance, like if 1/3 of the nodes try to do something else, it will be detected and it will prevent it from doing it.
Yeah, and it doesn't follow the crude that we use, create, update and stuff that is normally used in database. It has its own
So instead of update, it's append. Instead
Yeah.
of delete, it's burn.
burn, yeah.
So it's like that.
Okay, thank you.
Okay, thank you.